Over 50,000 Orange County residents were evacuated from their homes to avoid a massive chemical explosion. But here's what most news reports are leaving out. This was not just a leaky tank. Inside that tank, a chemical reaction may have turned thousands of gallons of industrial liquid into a giant self-heating reactor. The reason the situation became so dangerous comes down to one terrifying engineering problem. The hotter the tank got, the faster it generated heat. Tonight, we're going to break it all down. What actually happened, how close this came to disaster, what may have caused it, and what this means for Orange County in the long term. Everything unfolded at a manufacturing facility in Garden Grove, where a commercial and military aircraft company called GKN Aerospace houses a 34,000-gallon tank containing 7,000 gallons of methyl methacrylate, or MMA. MMA is a chemical used to make acrylic plastic, so things like airplane windows or plexiglass. Normally, MMA is flammable, volatile, and it exists as a liquid. But it also loves to react with itself, and it does so through a process called polymerization. Here is an MMA monomer. Think of this as a single Lego brick. Polymerization is when these individual Lego bricks begin stacking on top of each other into huge structures. So, what was once a liquid made of individual monomers becomes a solid plastic. Here's the problem. Polymerization is an exothermic reaction. It releases heat into its surroundings. But chemical reactions also speeds up when temperature increases. So now you have a feedback loop, which chemical engineers called thermal runaway. The reaction creates heat. The heat speeds up the reaction, which creates even more heat. And if this process accidentally starts inside a massive enclosed storage tank, well, we're essentially dealing with a giant uncontrolled chemical reactor. So one can imagine, in a situation like this, it is very important to monitor the internal temperature of the tank. The news has done a pretty good job with this so far. On Monday morning, as I was making this video, they updated us that the tank dropped temperature from 100 degrees Fahrenheit to 93. But here's what they aren't telling you. The sensor only records up to 100 degrees. So if the temperature reads 100, the inside could be much hotter. That's something that none of us knows for sure. Especially because giant chemical tanks heat up unevenly, like when you microwave leftover mashed potatoes and only one side comes out warm. Engineers call these local hotspots, regions where the reaction accelerates faster than surrounding areas. So we know now that firefighters are currently working to cool the tank by spraying water on the outside walls. But if the interior is much hotter than the outside, these measures may not be enough. So what happens if the tank continues heating up faster than it can cool? Well, you've probably seen PV equals nRT in general chemistry. It's pretty much the same concept. At higher temperatures, more MMA molecules escape into a vapor or gas form. It collides with the walls, and that rapidly increases the pressure inside the tank. With high pressure, the tank relies on pressure relief systems and vents to safely release vapor. But remember, as MMA polymerizes, it becomes sticky and sludgy like slime. In cases like this, that slime can clog the pressure relief systems, which is one reason the engineers were so concerned about pressure buildup in the tank. If the pressure in the tank builds up faster than it can escape, well, the tank can explode. Scenario 1. The tank ruptures. 7,000 gallons of hot MMA spill out rapidly. The liquid evaporates into a dense, highly flammable vapor cloud. And the vapor, which is heavier than air, hugs the ground. It flows onto the streets, the parking lots, drainage systems. It seeps into the soil and the water sources. And eventually, a car, cigarette, or some other static spark ignites the cloud. Large fires would spread to the evacuated zone, nearby neighborhoods, and surrounding industrial areas, likely within a 1-mile radius. Scenario 2. Instead of burning into several large fires, the vapor cloud ignites explosively. A pressure wave blasts outward through the evacuation zone, nearby residential blocks, and the areas closest to the facility. The wave is strong enough to create shattered windows, fires, blast injuries, debris damage, and very severe burns near the site. Orange County wouldn't look the same ever again. Let's all take a deep breath. Based on the latest updates, these worst-case scenarios now appear far less likely. Thank the Lord. On Sunday, officials confirmed that a crack in the tank may ironically be the saving grace. Because instead of trapping vapor and pressure inside a completely sealed system, the crack may have allowed gas to escape gradually, so the system is able to partially depressurize itself. And now the probability of a mass explosion has reduced dramatically. And here's some more good news. As MMA polymerizes, it slowly transforms from a dangerous liquid monomer into solid acrylic plastic, which is less volatile, less flammable, and less toxic than its liquid form. In other words, the tank may literally be curing itself into a safer material. And hopefully that means that we have got this situation under control, at least for now. Okay, now I want to address the question, how did we let the tank fail in the first place? And the truth is, we still don't know for sure. We will need a full-on investigation after the situation subsides. But chemical engineers on Reddit have a few leading theories. Normally, MMA storage tanks contain chemical inhibitors designed to prevent polymerization from starting accidentally. One possibility here is that those inhibitors degraded, failed, or became unevenly distributed. Another possibility is contamination. Some chemicals, metals, or peroxide compounds may accidentally trigger runaway polymerization reactions. And one of the most likely contributors is just lack of proper maintenance. Heat buildup, poor circulation, inadequate cooling systems, and lack of proper equipment. That raises serious questions about who is monitoring these systems and whether they are doing enough. It's unlikely that Garden Grove will become an abandoned, toxic wasteland. But that doesn't mean life simply goes back to normal. Thousands of residents were evacuated, businesses shut down, lawsuits and investigations have already begun. And so even after the tank cools, the psychological impact may remain much longer. For many residents, the fear itself was already real. Ultimately, I think the question we all gotta be asking is, how many other aging industrial systems are quietly operating beside densely populated communities, right up until the moment something goes wrong?